applications. That's pretty much.
Here I'm listening. I'll just keep my microphone muted so that.
Sweet.
All right, great.
Okay. So let's get started. This is where we left off last time. So this second lesson is about reading the version messages, right? Which is part of the version handshake that you have to do to communicate on the Bitcoin kind of peer-to-peer protocol. And so that's why we're doing it. And so, you know, we're basically trying to decode this payload that looks like complete gibberish except for this. And so, you know, we started by looking at this table, and these are all the things. We kind of did an inventory of all the new things we're going to have to learn to decode, right? So let's just kind of go through it. We had, so we had NetAdder, varstring, bool. Then we had kind of time, services, IPv6, and port. This is an integer, but it's going to be a big endian integer, so it's like backwards, which is super annoying. And yeah, I think within varstr we also need to learn varint. So we have all these different types, and even, you know, we have this. Yeah, this services is this thing called a bit field, which is like you know, it's basically how. I'll explain that when we get to it, but we did an inventory of all the things we need to learn. And then we wrote this version message with a bunch of a bunch of functions that aren't filled in yet because we don't know how to do these things. And so this is kind of like the first thing we're going to need to do in the lesson. We're going to need to learn how to make all these. We also, to do read timestamp. Okay, I'm making some little notes to myself. We're going to need to write some helper functions so that we can actually read the messages, right? So that's where we left off. So first we learned to just read integers from a stream, right? And this was an exercise. You know, hopefully you got it. And then we learned to read version numbers, which is we just used our readint function. And then we learned to kind of apply the read version number and basically figure out if a node knows how to send a Pong message. And then Boolean fields. Did we do this one last time? I think we did. Yeah, we did.
Yeah.
So bool is basically readint, but you just cast it to a Boolean just so our program makes a little more sense. We don't want ones and zeros flying around. And so that's where we left off. So we got a few more things. We have timestamp, right? And I just learned something really interesting about these timestamps. So this is, as we go, we're going to find all these places where the protocol is like kind of weird. So if you look at timestamp here, so here timestamp is, let's just a second. So this is, we're dealing with timestamps in the version messages, right? Timestamp is 8-byte field. Okay, that's cool. 8 bytes, that's easy enough. Now let's go to another one. Timestamp in a block. What the hell? Now all of a sudden this is a 4-byte field. Isn't that weird? So, and these ones will overflow in the year 2106. And if we keep going, you'll find that the different timestamps are. Here's timestamps, it's 8 bytes. So like, I just learned this yesterday. The protocol is inconsistent with how many bytes a timestamp takes up, which is really, it's really interesting. It's really interesting. And so here's an example of how to read a timestamp. I didn't have this as an exercise because I had, you know, this is just like something you look up. And so in Python, you have date time. This is how you like read a timestamp. You just import this thing and just, this will turn a Unix timestamp into a Python kind of timestamp. And so here's just a function that will do that. It reads an 8-byte integer and then turns it into a timestamp. And so the reason why we're doing 8 bytes is that in version message, the timestamp is 8 bytes. But in the future, we're going to have to change this code a little bit because sometimes this is 4. In a block, like when we're doing initial block download, this is 4, which is super confusing. So yeah, that's what it's going to be for now. But I'm just bringing this up as a kind of an aside. Like here's one of the places where the protocol is kind of confusing, and you got to pay attention very closely. Any questions about that?
So this is just Satoshi laziness. There's no.
Yeah, I mean, I was going to make a tweet about it yesterday. It's like I was going to say like Satoshi is either one person or he didn't know about, or they didn't know about code review. It's like these are things that would get in code review. These are things that would get caught. And yeah, I don't think it's laziness. I just think it's like when you're coding by yourself. This is my theory. Is like when you're coding by yourself, you can like miss these little tiny details, and I think that's what happened. Or something
surely that it's an obvious check to do that all variables are consistent.
Yeah, exactly. Yeah, I mean, who knows? I mean, it was just like a little garage project, you know, the original Bitcoin. It was just like a real.
Do they have different variable names? How does that even work? Like,
no, they have the same variable names. They're all called times. Well, I mean, literally, there are no variable names in this. There's just like how many. But I don't. Well, in the C++ source, like the original. Yeah, you can look this up. I mean, the Nakamoto Institute has some of the original.
Oh, cool! I didn't even know that.
Yeah, I mean,
I wanted to look at that a while
yeah,
back.
so you know, and it's only like a couple thousand lines. The programs are really small, so I don't know. I'd like this is one of the things I'd like to go and do in the podcast is if someone can like walk us through what these do. That would be very interesting. And so I don't know. We could you could look into this and basically understand that. But yeah, I don't know if the version, the variable names in this would give you your answer. But yeah, it's just confusing. It's like, it's a fuck up, you know, it's a bug. And it's gonna cause a hard fork, right? Like, you know, the 4-byte dates will no longer work in 100 years. Like, it won't work for more than 100 years. So you will need to hard fork, at least as I understand it, you're going to need to hard fork to change this, because starting on that year, you won't be able to represent that date, like the year 2200. You won't be able to represent in 4 bytes. It's too big. So yeah, it's a bug, and it's still in the protocol 10 years later because it's like so hard to change, right? How are you gonna? You once you make one of these in a peer-to-peer protocol, you're stuck with it, right?
That's a serious challenge to get into a soft fork.
Yeah, exactly. So
I suppose if they can do SegWit as a soft fork, then
yeah,
maybe anything's possible.
Yeah, but SegWit, at least you're adding stuff that can be ignored, right? Like this is you
can't ignore
nodes
this.
Are still compatible. When you change this, old nodes are now incompatible. They can't do this. So it's a totally different game, if you ask me.
Mm-hmm.
Yeah, so that's you know, it's a fuck up. But so even Satoshi was human. So yeah, so that's I'm just gonna give this to you. I'm not gonna ask you to do it just because it's kind of some trivia. But yeah, so that's now we know how to read a timestamp. And Unix timestamps are basically just the number of seconds since like January 1st, 1970, right? It's just it's just one of the many ways you can represent time, and timestamps are a huge, endless field of, you know, stuff. There's so much goes on in that, you know, we're just not going to dive too deep into that. So now we get to these variable length fields, and there's 2 of them, var_str and var_int. And we're going to start with var_int because to do var_str, you need to do var_str. Let me see where this is. to do variable length string or var stir, you need var int, variable length int. So you need, this is like a building block. So we're going to do this one first, and then as you can see, once we know how to do this one's easy, right? It's just like the payload message. You read the length and then read that many bytes to get the string itself. And the whole reason you do this is, like, let's say you have something that like sometimes could be 1,000 bytes and other times is 1 byte, right? You don't want to. Sometimes you want flexibility in how much data can be encoded. Like a Verac message has a payload of 0 bytes every time. A block message has like 100, a megabyte worth of bytes. So you need, you want that flexibility to kind of, and you want that flexibility to have content of different sizes, and that's what is accomplished in using the same technique of reading a length and then reading that many bytes in the kind of message structure itself. And this is just the same technique applied to other fields. And so the way this works is, so let's go to var int. And so you're going to want, I mean, this is a little confusing. So, okay, let's see. I'm going to just open up I could do this in Jupyter, but we're just going to do it this way. So, where is it? Okay, so here's some numbers. So you check. Actually, let me just look this over here real quick.
You remember to press record, didn't you, Justin?
Yeah.
Okay, good.
Thanks for checking. So let me see. So all of a sudden, okay, so if when we're reading this var int, you look at the first byte, right? And basically, if it's less than this number, and in Python we're just going to enter in this number, and so 253. This is a hexadecimal number, and so basically, if you read the first byte, and if it's less than 253, you interpret the whole thing. You stop reading. There's no more bytes afterwards. You just interpret this thing as a number, right? So like, so if you saw a byte that was x55, you'd say, okay, that's less than 253. And so we're just going to interpret this as the number, right? And so if the first byte is 253, then you read 2 more bytes after it, and you interpret those 2 numbers as your number. If the number is 0xFE, so 254, right? 0xFE. If the first byte is the number 254, then you read 4 bytes and interpret those as a number, and that's what your var int is. And if the number is 0xFF, so 255, which is the highest number, this is maxed out for a byte. This is the highest number you can get with a two-digit hexadecimal number. Then you read 8 bytes afterwards, and you interpret those 8 bytes as an integer. So yeah, this is confusing, or this confused the hell out of me when I first encountered it. And so yeah, any questions about that? We're gonna try to implement it. But yeah, any questions about that?
No, I'm good.
Does it make sense?
Yeah, it does.
I think so.
I just
That's
want
good.
to ask one question off topic. So is 1 byte always 2 digits or letters like FF, FE, is that always 1 byte? I mean, have the two of them in pair, or
Yeah, so
so for example, my question is, for example, if we have just one letter like just F, would that be just 15 actually, or?
yeah, so well, when you read them, so like if the number 16, it would look like this, or 15, sorry. It's, you know, when we have a byte string, it's just a series, you know, it's always like a series of these things. It looks like, you know, X, you know, AB. It's this like delimiter, and then two characters, and each of these is from 0 to F. And so yeah, if you had a 16, it would just have a leading 0. And yeah, that's, I think, I don't, does that kind of make sense? It's,
Yeah, I actually understand. You did answer my question. So there are always two characters. And
yeah, there's always two characters, and that's just because we're reading a byte string, right? Like there would be another way, I'm sure there's another way to do this where you're actually reading the bits. Like if you did it another way, you could just get, you know, 0s and 1s. But that's, yeah, it's just because we're reading, we're reading 256 characters at a time. We're reading 256 bits at a time. And basically I mean, just as a convention, the convenient way to represent those is something like this, right? Where you say, hey, there's 16 possible entries for each decimal place, right? That's what the X means. It's base 16. And we got 2 of them. So that means it's, like, that's just the convenient way that programmers have decided to represent these chunks of 256 values, you know, from 0 to 255. So that's, yeah, that's why there's 2 of them, is that's just what we're reading, that many at a time, just because it's basically convenient. Or it's what everyone does, I guess. I don't know a better answer than that.
all right, that's great. I understand it now. Thank you.
Okay, cool. So this is, yeah, any other questions? Cool, so we're gonna move on. So this is so I wrote a little function where I basically outline what this is gonna look like. And if we start from the top, right, we said the first byte of varint is a marker, which tells you how many bytes come after it, right? Okay, so when we write varint, well, let's read the marker. Let's just call it marker. Just so we can, our code's a little clearer. So the first thing we do is we read the marker, right? It's an int. So, and it's 1 byte. We want 1 byte of int. So we just call read int from the stream, get 1 byte. And then we're just following this chart, right? So we're gonna start with the biggest number and kind of go down. So let's check, okay, is it 255? Basically, if it's 255, let's read 8 bytes worth of integer afterwards. Okay, let's go down to the next one. If it's 254, then what do we do? So replace the fix me strings with the relevant code, right? And then so if we continue down to the third level, okay, well, what should the condition be, and what should we return, right? And then if these first 3 don't match, then what do we do? So that's this else condition. So I don't want you to just fill in these fix me's, just delete them like that, and, you know, type in, try to type in what a correct thing would be, and then you can run the tests down here. So you'll see my test failed because I haven't fixed it yet. So yeah, I'll give you a couple minutes to.
Yeah, I just have one question. So how does Python know that the 8 bytes that it should read exclude the first byte that we have already read?
Yes, good question. So that's the way. So the way we have this, the way all our helper functions work is any one of these read somethings. So where's read? Oh, maybe we didn't. I guess we did read int up here, right? So, where did it go? Okay. So the way we do it, right, is we do just stream.read that many bytes, and this stream. I mean, this is something I've kind of glossed over, and we should probably dwell on a little bit more. It's an instance of this bytes IO, and this is like a kind of an important. Okay. So it's a stream implementation of an in-memory bytes buffer. I don't know. Okay. So basically how it works is when you call read, you basically like throw away whatever you read, right? So when you call read, so when we call read here, readInt is going to call read on the little stream buffer, and it's gonna take that 1 byte and throw it away. So once we get here, it's like we've advanced. The stream has advanced 1 byte further. Like this stream and this stream are not the same. You know, at this point in the code, the stream has had 1 byte removed from it, right? So like every time you call readInt on the stream actually changes. As you go, you're consuming it. Does that make sense?
Yes, perfect sense. Thank you.
Yeah, you're consuming it. That's the way. Like we could call this. It might make more sense to say like consume int or something, right? Because you're actually sucking it out of the stream. All right, why don't you guys have a go and see if you can figure this one out?
Just say that I'm not on my computer right now, so I'm just watching from my phone. Just
Oh, you are? Who is that? Gustavo? Or
no, that's Ivo.
Ivo?
Yes. But I'm happy to share that I think I can see what the answer to
Okay.
particular questions.
Just doing it in your head.
Yes, indeed. Anyways, we'll be going through them again once we have some spare time. At least I did that to go through the notebooks again, so I'll have an opportunity to practice it.
Cool. All right, so let's kind of. I'll give you a little more time. 30 more seconds.
So basically, you have to follow the table on top, right? And on the else on the bottom, you just return the marker.
I can't really hear you very well.
Sorry, my internet connection is up.
Here, just a second. Let me put some headphones into my computer because I also have like my computer's headphones are really crappy. Okay. All right. Well, let's try it. So, sorry. What were you saying, Gustavo?
So basically, you have to follow the table above, right?
Yeah.
So for FA, we return the 4. For the FD, you return the 2. And then on the else, you return the marker itself, right? Because the length is everything. No, sorry, the length is everything that the marker says it is, right?
Mm-hmm. Yeah, exactly. So did you get to the test to pass?
I'm getting an error, but so.
Cool. Well, maybe the tests are broken. I'm not sure. So yeah. So the first one is. So this would be readInt 4, right? So if it's 4, we want 4 bytes, and that's the integer, right? And so we're basically going to throw away the marker, right? In this version, we just once we use, if this condition is correct, well then we're done with the marker. We're going to read an integer and return that, and basically throw the marker away. Same thing here if this is correct, and the same thing here, if the condition here should be if marker is equal to 0xfd, right? Because we're following this third condition. And then so lastly, if it's not, right, then we just want to interpret the marker as a 1 byte. The marker is our integer. So we just say return marker, yeah. So
I need to return the market.
yeah. Oh. And so yeah, then our two unit tests pass, and we're really smart. And
I have a question. Why not just always have the first 8 bytes for the length, and we don't have to do these calculations? Wouldn't it be easy? Just have the first 8 for the length, and then the rest is the int itself.
So the first 8 would be what?
The length.
Okay.
Instead of having to read the first byte and then convert it to length, why not just have, like, for default, first 8 are the length itself, and then the rest are the number?
If I understand the question correctly, like sometimes if the number is like 1, you don't want to wait 8. You don't want to waste 8 bytes saying that it's that just contains the number 1. Is that your question?
No, I'm just asking why, for principle, why they didn't create something like just say the first 8 are the length, and then the rest is the message. Because they don't want to waste the length, right? They don't want to waste the size of length.
Well, that's, I mean, they do that for the right, for this, that's what they do. For message structure, it's not 8, but it's 4. And so, I mean, there isn't actually an interesting question, right? Like,
just make it 8.
Well, yeah, well, no, but like, so this is a small part of the message, right? And you can encode an 8-byte, like an 8-byte number is really big. And so if you're, I mean, like var stir will never be, when you're doing var stir, it'll never be 8 bytes, right? Because the message length itself can only be 4 bytes, right? So yeah, it's that's a weird thing, like this if it's going to be, if this is going to be this, if you're going to use this to read a string, like obviously the number of bytes of this string, which is a small part of the message, is going to be less than the whole message itself.
Yeah.
But yeah, I mean, I think the reason is like in the extreme, it's 8 bytes, but sometimes, usually, I mean, for like what we're using it for is the, what we're using this for is the
variable variant, right?
Yeah, well, the user agent, right? And here's the user agent here, right? That's about 20 bytes. Each byte is a character. So it's like, we're not even, we're at the very bottom end. And if you look at like, all the nodes, this bit nodes is a place, like here are the user agents in terms of ranking, right? Like as this crawler understands them, they're all really small. So it's usually, at least in this case, it's almost all going to be one. You're almost never going to have like a really long user agent. Does that make sense?
Yeah.
Okay, cool. Okay, so where are we? So yeah, everyone good with this?
Yeah, I think so.
Cool. And now we're at varster. Okay, we know how to. Let's find it here. We would say, okay, we need to do varster. Let's go all the way. Let's just like go from the top. So we have a version message, right? We know how to do. We want to read the user agent, which is varster. Okay, let's go to varster. Okay, we need var int, and char is just to read a string. This is basic. This is just simple. So we need to do this, and now, okay, boom, we did that. So back to variable length string. So you want to read a var int, and then return, and basically whatever that var int, let's call it n. You know, that's just an integer n. So then we want to return just the next n bytes. Just read the next n bytes and return that. So let's do that. Let's implement that. I mean, it's pretty simple. It's, you know, just do what this table says and see if you can get these tests to pass, which they don't if you don't implement it. So yeah, give this a minute or something and see how it goes. Okay, anybody got the test passing?
No.
Give it a little longer then. Okay, well, I will show you how, if you don't got it by now, I think you're stuck. So I'll show you how to do it. So what we want to do, if you go back to the documentation here, the first thing you want to do is, like, the goal is to read a string of uncertain length. Okay, so what is the length of this uncertain length string? It's a varint. So the first thing we do is read varint. The thing we just implemented, and you just pass, you know, if you look up here, you don't have to pass any length or anything, because that's the whole point of varint, is it figures it out based on, it figures it out as it goes. And then we just say, okay, stream, let's say stir string. The string, the thing we want is, it's the same, this is the same thing we did with the payload, and like if you go here, remember when we read the payload? Well, I guess that's a bad example. We can kill that. So where are we? So yeah, we just want to do stream.read of length. And this is kind of my bad. I probably should have had you do some more exercises so you understand what the stream is. But the only thing you can do to a stream is read from it. That's all you do. And so when you read, you just tell it how many bytes you want. And length, this is an integer, so this will tell you how many bytes you want, and then you just return that string. So I think that's the answer. So the two tests pass. And yeah, read var stir, and then read that many bytes and return it. Any questions?
No.
Cool.
Yeah, that makes sense.
Yeah, so it's pretty straightforward.
Whenever it errors on if it's Jupyter or I've put the wrong thing in.
When there's errors, you don't know if it's Jupyter if you put the wrong thing in?
Yeah.
Okay. Yeah. I mean, yeah, Jupyter is kind of flaky sometimes. I don't know. It's like the most amazing thing ever, and then all of a sudden it like doesn't work.
Just my problem was that I tried to print that string, that
Oh,
value
okay.
string, and just crashed and did not return.
Okay. It crashed?
The test on if you try to
Oh,
run
okay.
the print string and then the button, it crashed. It
Yeah,
gives
I
an
mean, so there's just you're not experienced with Python, so yeah, you got to return it.
yeah.
So every one of these, yeah, with every one of these, we're trying to get a return value, and yeah, and so you'll figure it out. So yeah, there's that, and now so that's cool. And now we can read the user agent, right? Where did it go? Go back to, so now we can do this. We can read the user agent. Awesome. And so what's left, basically? Let's see what's next. So services. So this is like this little bit field thing here. Services, this 8-byte integer that's a bit field, whatever the hell a bit field is. And here's like a little guide to this is a guide to interpret it. Okay, so basically, I think this is the hardest thing to explain in this lesson, like what a bit field is. And so, if you ever, in Linux sometimes, or in Unix, have you ever, you have this script, right? How should we do this? So I make the script.sh, right? And so I'm going to edit it, and then I'm going to just echo hello. Like, this is the simplest shell script ever. And so, and I think well, actually, I don't think you actually need to do that. So we'll quit it. And then if we want to, if you want to just execute it, you might need so it's not executable, right? So if you do, I think ls-a, sorry, ls-l. If you look at ls-l will show the permissions. And basically these, if you're familiar with these Linux permissions, like, I forget which, but these are basically like, I think this is the user, this is like the group, this is someone else. I always have to look it up. I can never remember this. But the way you can set this is you do chmod change. You can change these permissions by like saying 777 means like everyone can read, write, and execute, right? So
You allocate 4, 2, and 1 to, what is it?
Exactly.
DR and W, is it?
Yeah, I always forget.
And then you have to add them up.
Yeah, you add them up, right? So basically, like so here's the table, right? So each one of these, so here it is. So execute only is 1, right? So let's do chmod 111 script.sh and then look at it again. Okay, so look, I just changed the things to, now they're all X's. So everyone can execute this script, and now, right, so I can go like this, and actually, you need, what the hell? Oh, maybe I didn't save it.
And then it just said changing a read only. Do you have the permission to write?
Oh yeah, you're right. I can't. So I can't edit the script now, right? Because I don't have the right. I don't even know why I can read that. Oh, I can't, right? You see, so Vim says permission denied. Vim lets me open up this file, but it doesn't actually let me open up the one that actually exists. So that's funny. So yeah, so that's funny. Like we created it so you can't read anymore, and like, look, I can't cat it, right? Permission denied, right? So let's make it so I can. I think the first bit is the user. So I can execute it, but I can't read. So if you look over here, read is 4, right? And so 4 plus 1, I want to be able to read and execute. So that's 5, and then let's just say, like, I think, is this, so now I can read it, right? Because this bit is me. So 5 is equal to 4 plus 1, right? And so this is actually a bit field. You don't interpret this as the number 5. You interpret it as how many of basically how many 1s does it have, how many 2s does it have, and how many 4s does it have. And the reason it's 1, 2, 4 is 1 is equal to 2 to the 0, right? And so that's like the 0 place. And 2 is equal to 2 to the 1. And 4 is equal to 2 squared. And so that's why it's 1, 2, 4. So this 7 is not like to be interpreted as the integer 7, like the integer that's, you got to look at how many 1s, 2s, and 4s does it have, basically. Kind of a shitty explanation, but so like now when we want to, like, just to finish this little demo, so script.sh, right? Okay, now I can read it. But when I try to delete this line, if you look at the bottom of Vim here, well, if you watch in my editor, if you look at the bottom here, if I try to delete this line, it'll be warning, changing a read-only file, right? Like I can't write to it. You know, so if I try to write, I'm trying to write, boom, read-only option is set. Can't read. So if we want to fix this, we do, let's let me do everything to it. So this is 7 is 1 plus 2 plus 4, right? So 1 means I can execute, 2 means I can write, and 4 means I can read. So once I do that, I'll be able to go in here and then say, hello, world. And let's do this. I think that's how you do this shebang. No, it's not. So it's backwards. So it let me write. Previously, it wouldn't let me write. And then we can do this way. You can execute it like it's a binary file. So that's what X means, execute. Obviously with a shell script, it's not that much different than being able to do bash script, right? Or like this. But with a binary file, it's like, you know, you maybe don't want everybody to be able to execute binaries because like that could be a virus or something real bad. So I don't know. So does that kind of make, so the point of this whole demo is like, you've all dealt with a bit field. This version thing is a bit field. It's this number 7 is how you 7, 4, 1, 5, however you can mash these together is you know, you by changing this bit field, these 4 digits, you can set all these different rewrite these permissions for these different people. So that's like, you've all dealt with this bit field before, and that's where you've seen it. And so if we get back here, where actually I need. Yeah, so if we get back here, we can see this is the table that's going to explain this bit field, right? So with Unix permissions, right, remember 1 is execute, 2 was read, right? Or 2 was write, sorry. So 1 is execute, 2 is write, and 4 is read, right? 1 is execute, 2 is write, 4 is read. And so here it's the same idea, but you have these different, like, it's basically these different things that your node can do. And for example, here, this is the only one they explain. So it basically, this node will let other people download blocks from it, right? So if this node's if a node is an SPV client, it doesn't have the block, so you can't download blocks from it because it doesn't have blocks. It can't serve blocks to other people. But it does have headers, so it can give you headers. And so for an SPV, this would be set to 0, right? This bit, like there would be no there would be no 1 in the sum of the integers, or in the sum of the values for this bit field. And so then you have a couple other ones. And so yeah, this is how to kind of interpret that bit field. It's sort of a long explanation, but the whole point is, like, you've done this before. It's not confusing. You can figure it out on Unix. You can figure it out here. And so yeah, let's go to
Just a quick
this.
question, Justin.
Yeah.
Why is if you go back to that table, why is it 1024 for the Node Network Limited and not 16?
It's a good question. I have no idea.
It's really weird.
Yeah.
Unless it's not, is it part of the same bit field? Is that just separate?
Yeah.
I don't understand.
Yeah. So the bit field is.
Does the bit field include that Node Network Limited?
Yeah, it does. So
Okay.
whereas services is 8 bytes, right? So how do you do this? Like 8 bytes is. So 8 bytes is so 8 bytes is 8 to the 8, right? Which is equal to like 2 to the, or sorry, that's how many kind of possibilities there are in an 8-byte integer, right? Because there's 8 of them, and each byte has 8 bits in it. And so this is the same as 2 to the, right? Because 8 is 2 to the 4th, or 2 to the 3rd, is it?
Yeah, 2 to the 3 is 8. It says, if you just go up a bit, it says that 10,024 equals 2 to the exponent 10 to the power.
Yeah, exactly.
10.
So what I'm showing you is, I think, yeah, so like there are 24. Okay, so that's actually incorrect. So it should be up to, I think, 23 then? Or, yeah, I don't know. So the idea is, so I'm just showing you that, like, there are this many exponents in this number. There are like this many kind of exponents. So there's 2 to the 1st, 2 to the 0, 2 to the 1st, 2 to the 2nd, all the way up to probably 2 to the 23rd. This is all the different kind of like bits that are in the binary expansion of this number. So like, so if we go like bin of 8 to the 8. So if we do len of, if we get the length of that and subtract 2, because there's these 2 leading things that don't mean anything. If we, I think that should be 20. So that's 20. Oh yeah, we need to subtract by 1 because we count 0, I think. So yeah, so this would be 20. Yeah, sorry, this is, I'm sort of figuring this out as I go too. So like this is basically how many, so yeah, what we want is this. We want 8 to the 8 minus 1, right? So this is like turning every byte on, and in an 8-byte integer. And so this is how many decimal places there are in the kind of the binary expansion of an 8-byte number. That's probably confusing as hell. I don't know. Does that make any sense? Like this is how many spots there are. And so far we've used up the 1 spot, the 2 spot, the 4 spot, the 8 spot, the 102, the 1024, which in terms of like which place is it in this expansion of the bit field, it's the farthest right bit, the one to the left, the next one, and this is the 10th bit. And so Michael's question is like, well, why don't we just go to 4 here? And I have no idea. I don't know. It's weird.
It's not that it needs a lot more different options.
No, you could just do 2 to the 4, 2 to the 4th. Like, it's a great question. I don't know. But the point is, like, you got a lot more room for other shit here, right? You could go, you know, we did the math here. There are 24 spots, and so far we've got 5 of them. So there are 19 spots left where we can sort of delimit other kind of services that our node can do. So, you know, there's room to grow here. And who knows why they chose to the 10th? Like, if we read the BIP, maybe they'd tell us. I don't know. There's the BIP, 159.
So just so that I have it right, it's the introducing it with the CH mod was really useful. So good work, Justin, on that.
Yeah. I mean,
just so that I understand it, if you had all of them switched on, say, on your node, then it'd be 1024 plus 8 plus 4 plus 2 plus 1, right?
Yeah, or I mean, actually, that's one possible answer, but it could be. I mean, this is another way. Like, there's more than one way to. Since there are kind of empty bits that aren't interpreted, like, there's more than one way to represent everything's on, right? Like, this would be a valid. If you just sent this would be a valid way of saying everything's on, right? There are other bytes, like the 4th byte, the 5th, or the 4th bit, the 5th bit, the 23rd bit. Like, every bit is on here, including the 1st, 2nd, 3rd, and 10th, right? So, like, this is a valid way of doing it, as funny as it is.
Maybe as you say, they just left it open in case they had more options in future.
Yeah, but, you know,
so
this leaves it open. Doing it in the 4th in the 4th power instead of the 10th power leaves it open just the same.
Yeah. Okay. I don't know.
People like the number 1024 is a cool number, though. I guess I don't know. But yeah, so there's so any more questions about that? So it's the whole point is, like, you've dealt with this before. It's not any harder than changing the, you know, getting your read-only file to be able to write to a read-only file. It's the same thing. And so the idea is, like, it would be cool in our software if we could, like, just produce a dictionary that would allow us to basically look up, like, okay, if we care about this node Bloom thing, it would be cool if we could just look up on that node, like, do they have that on or not, right? And that's what dictionaries are. They just allow you to look up values. And so this would basically be, if we want to write a read services function, just like we are doing for everything else, what we'd really want to do is read the 4 bytes. Well, I don't think it is 4 bytes, is it? There's a bug. So we want to read 8 bytes. Read 8 bytes, and then another bug. The dangers of pseudocode. So let's just, like, read this integer, this bit field, and, like, basically return this dictionary where we can, at each one of these, we'll check this bit field, like, okay, is the first place in the decimal is like the 0th place, right? Which is the same as 1, because 2 to the 0 is equal to 1. Is this on or not? Okay, is this byte, is this on or not? And so what we'd want is this magical just check bit that takes in a bit field and looks at a certain place in the binary, like the binary expansion of that, the binary representation of that number. And so this is the function that we want to do, but we just need this magic check bit function. And since this is, like, kind of obscure, and I had to look it up, this is how you do it. So what this basically does is, we can open this up again. So this is kind of obscure Python stuff, but, like, 1 this is like, let's take 1 and basically like move it over one, move that 1 power like over a couple spots. This is going to be hard to explain. Like, so this is like, yeah, so 1 is 2 to the 0, right? And then if you do this, if you do 1, it's like, well, let's make it 2 to the 1st power, right? And so if you do this, let's make it 2 to the 8th power, you do this, or 2 to the 3rd power, which is 8. You do that. So that's what this, it's called binary shift. That's what this operator does.
Mm-hmm.
And so it's a little more readable than being like 2 to the 3rd, because this one it's very like 2 to the 3rd. It's like you might be doing math, or you might be doing like it's kind of unclear what this means, because it can be used for so many different things. But when you're doing this, it's like it's very clear you're talking about like basically like bits. And so, you know, if we want to do, you know, what's this number going to be?
Yeah, 2 to the power 10, whatever that is.
1024, right? This is the other magical one.
Yeah.
And so that's what we do, is we just get I guess you call it I called it a mask. And then what you do is will be like, okay, when you do number and sort of like basically smaller number, I don't know how you'd say this. When you use this and operator, it checks if this number has like this kind of bit turned on, right? So let's choose an odd number like 7. Or let's go back to our read, write, and execute thing. So like, okay, remember when we talked, like 7 is turn everything on, right? So 7 and 1, so like, does 7 have the execute byte turned on? Yeah, 1. It's because 7 has everything turned on. Does 7 have the whatchamacallit, read byte turned on? Or write, sorry, 2 is write. Yeah, it does. And does it have the read byte turned on? Yeah. But does 4, which is just read, right? Does 4 have the execute byte turned on? No, 4 is just read. You need 5 to be able to read and execute. Does that make sense?
Yeah.
So it's basically just taking a number and like checking if, you know, it goes and takes 2 numbers, lines them up. Like it makes the, so here, let's do this 4 and 1, right? So bin of 4. How do I? Just a second. Python. Nah, that's, I don't know. I don't know how to make this look perfect, but like, I'll just like type them out. So this would be like this, right? 4 looks like that, and then 1 looks like this. I just want to figure out how to write pattern, right? And so and is doing is like, it's saying, okay, 1 is this binary number, right? That's how 1 looks in binary with like 3 places, right? So it just says, okay, 4 and 1 just says, okay, well, let's look at 4 here, and let's just see if this byte is on. Nope, it's not on. But for 7 would be like this, right? And so 7 and 1, let's check if 1 is on. Oh yeah, it is on. So that's why like 7 and 1 returns yes. So that's just how this magical function works. And like, if you want to go read the C++ source code, there's a lot of shit like this. You know, it's like bit flipping. There's you know, this is kind of when you do like C type programming, there's kind of a lot of this type of thing. And so yeah, there's like a very basic introduction to it. I'm a total noob at this sort of stuff, but any questions?
Not on that. A broader question is, so is this us contacting another node and requesting that it tells us what type of node it is?
Yeah, exactly. That's basically what the version message, like the two really important things in the version message is this, right? Which we saw earlier when we were doing the Pong thing, right? Yeah. Like, and we saw kind of how to look at it. Like here's basically a table. Here's a table. This takes forever to load.
Well, my question is, are there lots of messages being passed to and fro to get to this point? Or can you just go like, so you know the initial introduction was just version number being passed back to me from a node.
But it's version number, and so I'm trying to make a distinction between version number and services, like why they contain kind of different information. Like, so this table is like, you know, every node with this version number, like everyone is the same. It's like they either know this stuff. It's basically like this version number is basically like, you know when you're learning a foreign language, like I'm in Spanish 1 or I'm in Spanish 3 or Spanish 5, right? Like at least that's how it was in the US in like high school. You'd always say what, like, it'd be a number because in Spanish 3, it's like you learn how to, you know, call a cab or something. But in Spanish 2, you don't know how to do that. And so that's what these are. It's like you either have exposure to these new ideas or you don't at the lower numbers. But
then even if you're on the right version, you can turn some of these services off.
Exactly. And so so version is like hard coded. It's like it's like how many of these things have you heard about? You know, like how it's just like I have this code or I don't. Services is different. Like, you know, certain ones of these, like this newest one, you know, you have like SegWit and stuff, but you know, this node witness, I don't know what it does exactly, but it's related to SegWit, and you could turn it off if you don't want that. If you don't want your node, like if you want to be on the newest version of the software, but you don't want any SegWit stuff going on, whatever that means, you can turn it off. So that's kind of what services is like. It's like user configurable. So your remote node could have the newest version of the software, but it could turn a lot of these new things off, right? Like Bloom filters, witness, segregated witness. It can turn these off even if it knows about them. So that's the kind of difference between version and services. Services is something that, you know, the other guy can. I think it's just in the bitcoin.conf file, you know, your config file. This is what you can turn some of these on and off.
But the services information is exchanged after the version information and separate to the version information.
No, I mean, it's in the same message, right? Like,
oh, it is in the same message.
It's in the same message, yeah. So it's the first 2 bytes. And honestly, like the rest of this, like, honestly, doesn't really contain much information. Like, one of these network addresses is just completely thrown out. I forget which one it is. And in my testing, sometimes it doesn't seem like one of these is what they say their address is. And that's like worthless because you're talking to them. You already know what their address is or they wouldn't be responding, right? Like, and they could lie. They could say my address is like, you know, 8888 or something when it isn't their IP. And so one of these is like what they say their address is, which is you don't need to know that because you already know it. And the other one is what they think your address is. And like, I think Bitcoin just throws this one out. So it's funny. You have all these like fancy network addresses and they don't really do anything. They're valuable in another message, the adder message, which is how you hear about new nodes, right? So like in Bitcoin, you're always dropping connections to slow nodes. You want to get connected to good nodes that are awake. And so that one, the network address, is actually useful. So here's just another example where like this is kind of worthless. I guess start height is useful, but it's mostly these two that are, the version message has two important things, these two.
Okay, so just to clarify. So I send a message, my node sends a message to a remote node with my version, and the response is all of this. Yeah?
Yeah, well, no, you send them all of this. You send them all of this for you.
Okay.
Yeah. I should have probably done, like in a future one, we should probably do the whole, like we haven't done the whole handshake yet.
Okay.
I probably should have hard-coded one. Well.
The way my understanding was when you explained it before was that like there's lots of messages being passed back and forth, and the very first message that's passed is the version number, and then the node responds with their version number, and then you continue going with this back and forth communication.
Yeah, I mean that's mostly correct, but it's when I say I say my version number and you say your version number, that is this message. And there's more data than just the version number, but the version number is the kind of the most important thing, and that's why we call it version.
Okay, cool. I misunderstood that.
No, and well, I just didn't explain it very well either. So, so yeah, it's kind of drawn out explanation, but it's a complicated idea, and I think we actually kind of understand it now. And so here we go with our next function, like this basically takes this, so in this code, when I say services, I mean the bit field. I mean this integer, right? So I mean a sum of 1, 2, 4, 8, and 1, 0, 2, 4. Like it could be sum, like 0 would mean no for all. The sum of them would mean yes for all of them. So just to clarify, when you see services, that's what it means. So what we want to do is let's take this services int, right, which is just like, sum of 1, 2, 4, 8. It's some of these, either some of them or all of them. And let's turn it into this dictionary, right? Because that's what we said we wanted. We wanted to be able to create this magical dictionary. We could just look up what our remote peer can do. And so, hint, hint, look at this. That's going to basically be your guide. So let's write this. Let's write this ability to turn a services bit field into a dictionary that we can use, because a dictionary is a lot easier to use than a bit field, right? And then let's write a read services function that reads the right number of bits and turns this services int, right? So this services int is the same as this argument. Let's just call this function that we write and turn the bit field into a dictionary, right? So does that make sense?
I think so.
Give that a shot. And ask questions if you are confused. Any luck? All right, I'm going to start kind of filling it in over here. So.
Yeah, I'm just working out what needs to be returned.
Okay, here.
I'll
let you finish.
Thank you. Okay, I think I've got that right.
Where did check bit go? Oh. Okay. Well, here it is. So this part, you basically just copy what I put in the description here. And the way we got that in the beginning was you look up, you just look up the value for kind of node network in the protocol docs here, right? So node network, the value is 1. And so basically this is just like 2 to what power equals 1, or what's the natural log of this number, right? Natural logarithm of that number. So for 1, it's 0. Or for 1, it's 0. For 2, it's 1. So yeah, just look at, like, this is a pretty good explanation. It kind of, these numbers we get from the docs, and this is kind of how it relates to powers of 2. And whatever the exponent is, that's what goes over here. And so that should be pretty straightforward. And yeah, all we do, the only other thing we do is when we read services, we just got to read the right number of bits or bytes and turn it into an integer, right? So the right number is whatever it says here in our trusty table, 8. Okay, so we're going to read 8 bytes. And then we're going to read them with readInt, right? Because readInt is our helper that just reads 8 bytes and turns them into a little endian integer. So that's what we want here. And so if we do that, read 8 bytes, interpret them as integer, and then turn that 8-byte integer bit field into a dictionary, because a dictionary is a lot easier to deal with in Python world. And run them both, and the test should pass. Any questions there?
No, let me just compare what I got.
No.
Okay. Yeah.
Cool. So to move on, so the next couple things are basically going to basically be try to like use this little bit field to understand things. So if we just execute this next cell, all this does is it iterates over a list of these kind of integers called that to be represented as bit fields. So like here is 1, right? This is only with the first bit turned on. Here's 8, right? This is the fourth bit, right? Because 1, 2, 4, and 8. 8's the fourth power. So this is just with the fourth bit turned on. This is 1 and the fourth bit turned on. This is 1 and the 10th, or this is the third and the 10th bit. Here's everything. And here's a bunch of stuff that is not even included. These are bits that are, that should actually be like 21. These are bits that are kind of out of scope. These ones here, they're just like, these are things that that aren't don't have any meaning in our bit field. So if we execute it, we see that you can just kind of look through and see, okay, for 1, that means node network. Remember, that was the first one. That's on, and everything else is off, right? And for 8, that would mean, see, 8 node witness. That means just node witness is on. Everything else is off. And so I'm not going to explain every one of these, but you can just kind of go through this list and you say, okay, for this number, like all of a sudden we have this nifty little dictionary that can tell us what's on and what's off and all that. So, yeah.
Put them in the right order, right?
Yeah, so it's a good question. I don't know why. So you'll notice that they are in the same order every time, and I know, okay, so in Python 3.6, they added, like in Python 3.6, they made dictionary keys ordered, but it was something that they didn't want you to rely on. It was just like, hey, we made this optimization, and now accidentally kind of the dictionary keys are ordered. That's 3.6. Python 3.7, the newest version, now says like, okay, this is something you can depend on. It's just assume that the keys are ordered. And so you'll notice that they are in the same order every time. So I would think they would be in this order. So I don't really know. Okay, but you can see it's alphabetical, right? So they spit them out node B or lexical order. So it just says like, see, B comes before G, G comes before N comes before W. Network is a shorter word than network _ limited. So these are, yeah, I mean, we could update that. That's actually a good point. You could do like fix me.
Certainly make it easier for the human.
Yeah, that's a good point. I mean, and that's exactly that's why we did a dictionary, is because it's a little easier to deal with than an integer, right? And increasing. Yeah, I'm actually not sure off the top of my head how to, because this is like a new language feature. This is just like Python 3.7 basically, where you're supposed to be doing this. So I don't know how to tell it to, I mean, we could just like, we could say, hey, you know, D is equal to this. And for each one of these, do like D of this, you know. If we did this each time, I think it would actually return. I don't want to, let's not do this now because it might not work. But yeah, so I'll get back to you. There's a way to do that, and I'll just put a fix me in there. And when I go back and try to figure that out, there's a way to do it. Good point. All right, Gustavo, where is it working for you? Making sense?
Yeah, it makes sense.
Ivo, you still there?
Yes, I am. It does make sense.
Oh, that's good to hear. And Michael lets us know every time, so I think it's working for Michael too. So here, let's move on. And so here's like another one, just like we did with the version message, right? We're like, well, can it do Pong? So here's another one, like, let's create this services bit field. And so just making a note to myself. Sometimes I'm calling it services bit field. Sometimes I'm calling it services int. And they mean the same thing, but I need to just choose one definition. So you know, just take. Huh?
That's a Satoshi error, that is.
Yeah, exactly. Yeah, that's.
We'll make a Satoshi of you yet, Justin.
Yes, that's. I mean, I'm pretty much there. Let's be honest. So let's just take that. Let's use this function we just wrote. Services int to dict. Let's take that and basically write a function that can say, well, hey, can this do node network? Is the node network bit on, right? And so previously you'd have to go like the way to do this raw would have been like this, like return like and one. Like that's, it's short, but like to me that's like, what the hell is it doing, you know? And so, you know, for example, this one would have been like, yeah, let's just do it this for maximal confusion, right? Or node bloom, and so that would have been node bloom is 4, and then node bloom is 4, node witness is 8. So then you sum them up and it would be 12, right? So that's how you would have done this before. Super confusing, right? Let's just say and 12. Now we know, like that's super confusing. So let's use let's use our function services int to dict, and then look up the relevant key to see if it's on or not, you know. And for this one, you're going to have to look up both of these keys and return like, you know, first and second. That's how you do it in Python, to return a conjunction. If you want both of them to be on, return something and something else. So yeah, why don't you try that for a minute or so, see how it goes. All right, let me know when you're either finished or you give up.
So this is exercise 8, is it?
Yeah.
Okay. And what's the raise not implemented error for?
So raise not implemented error just is like a way of saying like, sometimes you can like, when you're kind of sketching out how a function will work, you can like define some, like you can define some functions that are like, this is, you're just saying like, this is what I want it to look like. Like when you're writing a big program, you know, a good way to start is to do this. Like write what you want your classes to look like, and then like kind of whatever helper functions or whatever functions that you haven't defined yet, you just write what kind of the interface, like what you want it to look like, how you want it to work. But you just raise implemented error, not implemented error is just like if you call this function, it'll raise an error. And it just says, I haven't been written yet. And it's just a way of like sketching out what you want it to look like. So
okay.
For this purpose, it's a way of making the tests fail until you fix it. So you just delete that.
I cannot get it to work. I know that you have to convert it into dictionary, but after that, I just give me an error.
Okay. Well, let me. I'll try the first one. Let's try the first one, and then I'll let you try the second one. You're on your own. Where the hell are we? Okay, so the first one, I'm gonna delete what we had here, and let's get services int to dict of serve. So I'm just gonna rename the input as services int. Just for clarity's sake. So that's pretty simple. Like that makes sense, right? Services int to dict of services int should be services dict. Okay, there you go. And then let's just let's say node network on is equal to services dict of, that's the key, right? For node network is that. So node network on, or let's just say, let's just use the same words, offers node network is equal to that. So this should work. I'm just going to comment out this test. Oops. And so yeah, this test, that's weird. Interesting. I wonder what the, oh, okay, that's, Okay, so that test works. They ran and they worked. So does that kind of make sense? Gustavo?
Sorry, that's it. Yeah, so it was a language problem, but yeah, it makes sense. So you get the object, and then you try to get the attribute of the object, and if it's there.
Okay, so now how about you guys try this one, right? It's going to be the exact same thing. The first thing you're going to do, but you just have to do this step twice, and you have to return the first one and the second one. So
for the node bloom and node witness, right?
Yep. So yeah, so you're just going to look up two keys here, and just make sure that they're both on. You know that they both return true. So I'll give you like a minute and let me know if you're stuck or if it's working. All right, how are we doing?
It's working.
It's working. There we go. Michael, how's it going for you?
Just an indentation error. I think it's the return and.
Yeah, so I'll just start kind of coding it up here and then.
Oh, okay, yeah, I'm good.
Cool, yeah, so for the viewers at home, and I'm just going to copy what we had earlier, and we'll say instead of offers node network, we'll say offers node bloom. And then change this key, node bloom, and then the other one we need is node witness. So node witness, and go over here, and then let's say offers both is equal to offers node bloom and offers node witness, right? And just take the conjunction and let's say return offers both. That's our return value. So hopefully we gotta uncomment the services int. So I remember I just changed these names because I didn't want to. It's the same thing, and I'm changing what it's called, which is stupid. So yeah, I got them all to pass. So sweet. So we kind of know how to use. So that's pretty cool. We know how to say, hey, can your node do this just based on some random number? So that's cool. We've you know, we've conquered the bit field here, which is kind of, in my opinion, the second most interesting field on this message. And so, so that's great. And now the last thing is network addresses. And so let's see how let's just refresh myself here. Yeah, so after this, we're going to actually, so we just have one more step until we can read an entire version message that someone sends us. So, so that's cool. So yeah, here let's look at the table they give us. So this is NetAddr, and so it has time and services, right? And we did time earlier. We just learned how to interpret services, and oh, here though, look, we didn't actually learn how to do time, right? So look, this time is 4 bytes. This time is 8. So I guess 8, this one's called timestamp. The one down here is called time. So look at that, bug in the code. I previously assumed that these, so fix me. So not the same. So yeah, so we're gonna have to kind of update that on the fly here. And so time, and it's also weird. It says like, okay, time, now it's 4 bytes. It used to be 8. Okay, super confusing. And then here, so for version above that number, so for this one, we're just going to ignore that because we're usually not dealing with these old ones. But you know, we should, in a future version of this, I should include this. I don't even know what it means. So maybe this message isn't included in old versions. I don't know. And then here it is. If this network address is being included, if it's like a part of the version message, because it can be in other network addresses included in all types of messages. So if it's included in a version message, then time doesn't show up. So here's another thing, like this is convoluted as hell. This is like really confusing. And so, okay, so that's confusing. Now services, we know how to do that. IPv6 and port, this one we're just, you know, it's kind of confusing, but we're just going to use a library that knows how to deal with IP addresses. So we're not going to have to dive too deeply into that. And then port is an integer, right? uint16, so a 2-byte integer, but it's network byte order. Network byte order is big endian. Remember how every integer we've dealt with is this so-called little endian? So this is like the direction of the bytes is backwards, left to right wise. It's like switched. And so this is another thing that's kind of annoying that Satoshi couldn't kind of make up his mind, or I'll just say his rhetorically, couldn't make up his mind and gave us this in this silly direction. Not silly, but like it's just inconsistent. And so yeah.
I thought Bitcoin Core didn't support version 6, IP version 6 addresses. Is it?
Yeah, I don't know. Basically my only experience with it is for this little table. Like I haven't really mucked around with it too much. So
because I looked into this because ideally with IP version 6 you don't need to have private IP addresses, because you can just give every device an IP version 6 address.
Yeah.
But when I was looking into this, it said Bitcoin Core, like even the latest version, doesn't support IP version 6. But maybe what I read was wrong, or
yeah, so it supports them. I mean, I've seen IPv6 addresses. Like you can have IPv6, IPv4, or onions. These are really a pain in the ass. We're gonna have to deal. I don't know how to even deal with these in Python yet. Like I don't know how to do a Tor connection through Python. So
I'll look into this. I'll look into this after.
You can, and yeah, so we're gonna like not really pay much attention to how the specifics of how these addresses work. We're just gonna throw the Python IP address module at it and hope it works. And so here's a little table for the address. Like this is kind of what we did. Here's just a class. So these fields are just the same fields as you see in the description column. We're going to have the same thing where we can kind of like read it from one of these byte streams. And remember here, so it's like not present in the version message, right? So we're going to have like a flag that just assumes we're not dealing with a version message as the default. And so by default, this will be false. So this will be false. And so by default, it'll always read a timestamp. But if you're in the context of a version message, we'll allow you to pass in a true here, and then it doesn't read the version, or it doesn't read the timestamp. So that's confusing. I'm just trying to basically encode what this table is telling me. Like this timestamp is not included in version messages. All right, I'll just give the calling function a way to say don't read the timestamp. And we could name this like include timestamp or something. I don't know, because it gets kind of convoluted. And actually, like, this, so yeah. And so there you go. And so actually one complication here is that this is actually not correct, because read timestamp so read timestamp is by default reading is reading 8 bytes, and actually in this context it needs to read 4. So I'll just say, like, I'm just going to show you this code since we're kind of already at 2 hours here. So I'm just going to show you this and just tell you this is broken and we need to fix it. So here's how to do the kind of class method thing we did earlier. It's getting a little more convoluted though. And so to implement read IP, I mean, since we're kind of, I'll just kind of show you how to do this. So you want IP equals, so to do read IP, you're going to want to we got to figure out how many bytes we need, right? So here it says 16 bytes. So let's read 16 bytes. And let's turn them into an IP address. I think. And let's return the IP. So IP address is just some magical thing that's built into Python that knows how to deal with these. So great, we can outsource our work. And so that works. All you got to do, read 16 bytes, turn it into an IP address, and the test pass. Cool. Any questions there? Take that.
No, I mean that's IP version 4, right?
No, well,
So
it actually handles either one.
okay, fine.
This is smart. It can. It doesn't handle onions though. So in the future, this is going to break when we encounter onion addresses. So, well, I actually don't know how it works on an onion address. Like, yeah, I don't know what those. I've never connected to a node that is running on Tor, so I don't really even know how it works. So I
think maybe I'm wrong again with this, but I think nodes by default are run on Tor. Or at least my bitseed was. My bitseed had Tor enabled by default.
Yeah, I mean, they're not going to run but you need Tor installed to be able to run it on, like,
yeah,
run it on Tor, right?
But I think Tor has been pre-installed onto like the bitseed devices.
Well, support for it, or bitseed. Okay, yeah, I don't know anything about bitseed. Yeah. So here is and so the last one is port, and so I'll just kind of do this one for you too, since we're running low on time. I mean, if you're watching it later, you can pause here. So we want to return read bytes of stream 2, because it's a 2-byte integer, right? 2, see? But then it's big endian, right? So we actually have to, I think we could do byte. Remember when we read int? Remember when we wrote read int, we had this byte order. This was yesterday. We had this optional byte order thing, right? That was by default little. So here we're going to actually say, no, I don't want little, I want big. Like, this is one of the rare cases where we actually need big endian. And so that's what we do. We pass it in as big. And so we just return this. We're just reading 2 bytes, interpreting them as an integer, and not just any old integer, a big endian integer. And so if we run that, the test will pass. And so does that make sense?
The port is in big endian. Yeah, I think so.
I mean, yeah, this is like, it's fucked up. Like, the bytes are backwards. Like, so this is just like any other integer, right? But the bytes are backwards. And so
why is it not saying the table it's in big endian?
Network byte order means big endian.
Oh, okay, fine.
That's it's another word for it. Okay. So yeah, again, this is super confusing if you don't have, if you have to figure this out on your own. This took me a while to get what was going on. Network byte order means the same thing as big endian byte order. So
handy to know.
Yeah, handy to know. That will, if you don't know that, all your shit will be exactly backwards, which is not good. So yeah, there's that. And now we're at the end of our thing. Here is the same code we did last time, right? But last time we just didn't have, we basically just added one line, right? At the beginning of our class, we had yesterday at noon, we knew how to do this. Get to the, we should probably say packet. So this is like the kind of the packet, but we just had this payload, right? We don't know what the hell it means. Well, now at the end of the class, we can actually take the packet, we can make a payload, we can make a version message. Remember, this is the class we've been working on this whole time. This is the thing that we kind of started up here with. We have all these things that we, did we redefine this? Okay, so here I I just import the thing from the complete file just so we don't have to, we kind of changed a couple things. So this is like the final version. So let's just, you know, get this whole thing, take this class and just read do from bytes on it, from bytes on the payload. And this just allows us to interpret the payload and turn it into a version message, print the payload, and I have a printing thing that can turn, when you print it, it'll turn it into a nice table. And so when we execute it, boom, we go talk to a node, we get their packet, the kind of the message structures. It's just like the, you know, what command it is and how many, and what the payload is. And let's take the payload and turn it into a version message. And boom, here's a version message, right? Here's a number. They have node network. They don't have node get UTXO. So this probably means, like, I don't know, maybe it's like some indexing thing, like you can get specific UTXOs from it. I'm not sure. Here's a timestamp, right? That is now, right? 1442, look down here, 1442 or 43, so that was a minute ago, or, you know, a couple seconds ago. Here's an address. This is what they say their address is, I think. I'm not really sure. These basically, nobody uses these, to be honest, I think. And here's a nonce, just a random number, a user agent, remember? Here's what block height they are, so I bet that's what the current block is. So let's look. So I'm gonna copy that number, current. So that's the number we had. I just copied that, 536,484, 536,484, boom. So this node that we just talked to is up to date. It's at least according to blockchain.info. And then here's something a little weird. Relay is none. That's actually unexpected. It should always be true or false. Let me just look into that a little bit. Oh, look at that. My read bool function, I don't have a return value. That's bad. Okay, so let me, oops. Oops. So, but remember, at the beginning of the lesson, we did this thing, we turn on auto reload. So usually you'd have to restart the whole Jupyter notebook, but after we edited that, we should just be able to run this again. It'll import the newest version of the code. And now relay is true. So
very nice.
Fix the bug. And so this is, who knows what that's from. And so there we go. We have a report. Now we can actually read version messages. How cool is that? And so just as a little demo for a pitch for next time, like the next lesson, I think I got kind of carried away. The next lesson, we're going to go and basically download every version message in the whole network. I'm going to teach you how to do that. This lesson is like absolutely insane. And like, I'm going to teach you how to so here's some code that we did to try to download all the messages. See how we're doing them one at a time. So I'm going to teach you how to download a bunch of them at once. So like basically this version of it, there's one slow one, right? But this version of it takes like half a second. This version of it takes like 15 seconds to download like 50 messages. So it's cool. It's like it's a way to kind of download a bunch of tasks from a bunch of different nodes. And the reason it seems like it's kind of a random thing to do, but we're going to need to know how to do this style of programming where we talk to multiple nodes at the same time when we write our initial block download, right? Because in an initial block download, the first thing you do is you download the headers, which are really fast. It takes a few seconds, at least when I did it. And then downloading the blocks takes like a day at least. And so when we're downloading the blocks, what you do is you download specific blocks from different people. from different nodes. And so your program has to be able to talk to like 8 nodes at the same time. And so we're going to like learn some of these techniques to talk to multiple nodes at the same time. And as you can see, by the end of it, it gets pretty, some of it gets pretty crazy. And so I'm still like, here are onion addresses. Look, my code still breaks on onion addresses. So yeah, this is what we're going to do next week. This is like super interesting stuff. So yeah, let's talk, meet any questions. This is what you have to look forward to.
Looks cool.
Yeah. Thanks.
Is there anything we should be looking at before next lesson to make sure we understand?
I mean, one thing, let me think about it. I mean, I'd say go through this lesson 2, go through 1 and 2 and try to like, maybe do the exercises over again. If you want to, and just to kind of nail in your understanding of things. I could think of some sort of, I mean, we had that homework last time. I don't think any of you got to it. Or did any of you manage to attempt that?
I did a little bit.
Huh?
I looked at it.
Yeah. I worked around a little bit with it.
I looked at it, but my Jupyter Notebook wasn't working at that point.
Oh, shit. Well, I mean, I honestly think that would still be an interesting lesson. Like, because if you saw, like, what we did this lesson was basically the same as what we did last lesson. We're just like trying to interpret different types of data from this protocol documentation. And so, what that, that message had, that homework had, where is it? No, that one had blocks. It had headers. So these are 2 things that it has, and it's like, if you can go pull one of these out of that file I gave you guys, try to like find one block and try to actually, try to read these. This one's pretty simple. Look, we know how to do every one of these. Character. These are hashes, integers, varint. We know that. And here's a transaction, like a list of transactions. Now, these are going to be hard because transactions have a lot of stuff in them. But this is basically, you could try your hand and see if you can, at least like get the timestamp to be the current time. Like that would be good. And here's headers. These are a little simpler. So these are, you can take that little file I gave you and try to decode some of these. And, I think a lot of you, this one, headers especially, like this is pretty attainable. There's nothing crazy going on here. You could actually decode that. And I mean, this is what I was learning how to do like a month ago. Like when I was first thinking of kind of making a class out of this, I was trying to figure out how to do all this, and it's not so bad. So that's what I'd say as the homework. Just try the old homework again.
Cool. Sounds good.
Nice.
Yeah, sounds good.
Well, cool. Well, thanks for putting up with me, and yeah, I'll see you guys on Slack.
Sounds good. Cheers, Justin. Cheers, Eva.
Great. Thank you.
Bye.
Yeah,
Bye.
take it easy, guys.
Goodbye, Justin. Goodbye, guys.
Bye, guys.